What's going on, everyone? So today we're going to attempt this integral, okay? It came up on my homework assignment, and I think it's worthwhile to try it out. And of course, it's on the integration by parts section, so that means we'll have to try it, using the tabular integration method or just the classic integration by parts method. And it's good to point out that the tabular integration method has been deleted from the 14th edition of Thomas's Transcendental Calculus, which is pretty sad. But I mean, it's the easy way to do an integration by parts. So I'll show you later what I mean by that. But first, I'm going to solve this using a different method, very common method, u substitution. Okay, so basically, let's say that let u is equal to the square root of x cubed plus 3. Okay. So in that case, du will be the derivative of this, right? And the derivative of this, we have to, for that we have to use the chain rule. Okay, so the derivative of the inside, which in this case is 3x squared, and then multiplied by the derivative of the outside, right? So that's going to be times a half, right? So that's going to be 2 on the bottom. And then the same function. So this to the power of 1/2 minus 1 is negative 1/2. So that's going to be the square root of x cubed plus 3 dx. Okay, now pay attention to this over here. Now, because of the nature of repetition of square root functions when you derive them, we can say that, this over here is u, right? Because it's essentially the same as this. So that's going to be our u. So let's substitute that in and see what happens. So in that case, du is 3x squared dx divided by 2u. And so dx is going to be du times 2u divided by 3x squared. 3x squared, yeah. Okay, so let's substitute these two values in this function, this equation here, and see what we get. So we got the integral of x to the power of 5 times u, right? And then dx is going to be 2u du divided by 3x squared. Okay? And now look at this. X to the power of 5 divided by x squared is going to be what? Okay, that's going to be x to the power of 3. So we have integral of x to the power of 3, and then u times u is u squared. And we have 2/3. So we can bring the 2/3 outside of the integral, and we have times u squared du. Now we just have to find what x to the power of 3 is. And as you can see, in this u substitution over here that we made, we can actually solve for x cubed. So let's solve for x cubed over here. So x cubed is just u squared minus 3. Okay, so we can substitute that in there. So we have 2/3 times the integral of u squared minus 3 times u squared du. And then we can, spread that out, and then let's see what we get. We get 2/3 integral of u to the power of 4 minus 3u squared du. And that's essentially 2/3 times u to the power of 5 over 5 minus 3u squared integrated is going to be 3u to the third over 3. 3 over 3 is 1, so that's u to the power of 3 plus c. And then we plug that back in, it's going to give us, 2 over 3 times 5 is 15. And then we have x to the third plus 3 to the power of 5/2 minus 2/3 times x cubed plus 3 to the power of 3/2 plus c. That's going to be our answer for this problem over here. And as you can see, u substitution is probably like the most straightforward way to do it. And I didn't even, I tried using integration by parts, but it's just too much work, It's kind of hard to choose, to see which u and which dv you're going to use. So that takes a lot of time, but it's worth looking at it. Now I'm going to show you next, of course, how to do integration by parts if you haven't done it yet. You probably went to your first lecture on integration by parts already, so I'm just going to skip on the first steps of it. So we just know that, okay, integral of u dv, okay, is equal to uv minus integral of v du, right? And as you know, this comes from the product rule, right? This comes from the product rule. So let's say, for example, that you want to integrate, okay, x squared cos, okay, 2x. So we could choose our u to be x squared and our dv equals cos 2x dx. Why did I choose u to be x squared? Well, because u is always differentiated. U is always differentiated and dv integrated. Okay, that's the pattern in integration by parts. And as you can see, when you differentiate x squared, at some point you're going to reach 0. Okay, so that's the advantage. So if we use the classic integration by parts procedure, okay, I'm going to show you how to do it. So it's going to be like this. So it's uv. So if we choose our u to be, for example, u is x squared, right? And so du will be 2x dx, right? And then dv, we chose it to be cos 2x dx, which means that v is integral of this, and that's going to be a half sinh 2x. All right, so that's going to be uv, right? So that's going to be x squared sinh 2x over 2 minus integral of v du. Integral of v, which is this, 1/2 sinh 2x, and then du, of course, is cos 2x dx. Okay? And all of this is equal to this. Integral of x squared cos 2x dx. Now, what happened here? Well, wait a minute. This is integral of v du. I did v dv. Yeah, no, this is not how it is. Wait a minute. I apologize. Minus the integral of v. Okay, v in this case is a half sinh. Okay, so that part was right. I have sinh 2x, and then du is not this. Du is this. The v's and u's are kind of like confusing. So it's going to be 2x dx. And we can use the same procedure. And 2 over 2 is 1. Okay, so we can say u is equal to x. When we differentiate that, you get 1. And your dv can be sinh 2x dx. So let's do the same thing. The u is equal to dx, and v is integral of that, which is a half cos 2x dx. Okay? Now, let's do that again. So that's going to be equal to x squared sinh 2x over 2 minus uv, which is going to be, okay, x over 2 cos 2x, and then minus the integral of v du. V is this, and v is this, I'm sorry, and du is this. Okay, so it's a half cos 2x dx. All right, so that's going to be 1/2 cos 2x and then dx. And finally, we can do this integral. This is, you know, the most basic we can get to. And don't forget the parentheses, outer parentheses over here. Okay, there's that, because we have to distribute the negative. So that's going to give us, okay, x squared. So the final answer, ladies and gentlemen, is going to be x squared sinh 2x divided by 2 minus x over 2 cos 2x. Minus times minus is positive, so plus 1/2 integral cos 2x is going to be 1/4 sinh 2x plus c. Okay, don't forget that. That's going to be the integral. Okay, using the classic method, the classic integration by parts method, right? This is the one that's on the newest edition. So if you take a test, you will have to show it, okay, the process using all these steps, which is kind of annoying, because there is an easier way to do this, and I will show you, which is tabular integration, also known as the DI method. Okay, so it's very easy because we can just like cross multiply, and it's just like straightforward. You don't have to write too much. So what did we have again? We had integral of x squared cos 2x, right? Now, using the DI method, so here on this side of the column we differentiate, and on the other side we integrate. Here we have an alternation, okay? We have alternating signs, so plus, minus, okay? And over here, we're going to put our u. We said our u was x squared, so that's going to be x squared, and our dv is cos 2x. Now when we differentiate, we get 2x. When we differentiate again, we get 2, right? And then when we integrate this, you get a half sinh, right? 2x. If integrate this again, is a fourth cos 2x. Oh, we have to differentiate this once more. It's going to be 0, okay? And then let's integrate this once again. So that's going to be 1 over, okay, 1 over 8 times 2 is 4, 8. 4 times 2 is 8, so it's 8 sinh 2x. Okay, so then here is the thing, okay? We already have everything laid out. We didn't have to, write so much. So that's going to be like this. You just cross multiply like that, okay? This times that, and then this times that, and then this times that. And let's see what we get. All right, so that's going to be equal to x squared over 2 sinh 2x, and then minus, okay, minus 2x over 4th cos 2x, and then we have plus 2 over a sinh 2x, okay, plus c. And then we can simplify a little bit. This is 2 over 4, which is a half, and this is 2 over 8, which is a fourth. Okay, so our final answer is, of course, x squared over 2 sinh 2x minus x over 2 cos 2x. And then we have plus a fourth sinh 2x plus c. A way faster way, okay? This is way faster to find an integration by parts problem, the DI method. And then, of course, some professors think it's cheating. It's like using calculators. But I mean, it's a quick way. And also, I mean, if they don't let you use this on the test, just use the regular method and use this to check your answers. Okay, that'll be great. Yeah. So let me try another problem, another example of integration by parts, and I'm going to use the DI method because I think it's just way faster. Okay, it's the shortcut, the good way. Okay. Now, this integration by parts is going to be a little different. So let's say you have cosine of, okay, I don't know, 3 theta, and then sine of theta over 2 d theta. And you want to find the integration of this, okay, using integration by parts. So let's use the DI method. Differentiate, integrate. And in this case, it doesn't really matter, as you can see, because both of them are trigonometric functions. So it doesn't matter which is your u. You could say u is sine theta over 2 or cos 3 theta. It doesn't really matter. But let's do let's do u is equal to cosine 3 theta. Okay, so over here we're going to have plus, minus, and then our dv is going to be sine theta over 2. Okay. Now we're going to differentiate all this, but we're going to stop. We're going to stop once we go back to cosine. So it's basically at the third row, and I'll tell you why. Okay, so let's differentiate this once. That's going to be 3. Okay, negative 3. Yeah, negative 3 sine 3 theta. Let's differentiate negative 3 sine theta. That's going to be negative times negative, right? It's going to be positive, so that's going to be 9 cosine 3 theta. And then we stop here because we have the same factor over here. Now, let's integrate this. We're going to have integral sine theta over 2, which is going to be 2. Okay, negative 2 cosine of theta over 2. Integrate negative cosine theta over 2. And that's going to give you negative sign, right? So that's going to be negative times negative is positive. So that's going to be 4 sine theta over 2. All right. Very good. So Now, oh wait a minute, this is actually integral of negative cosine theta over 2 is negative. Yeah, so this is negative. Negative stays there. And right here I think it's the same. Differentiated, okay, once this is going to be negative sign and then negative cosine. Yeah, so the negative is still, okay, still there. And that's because of this. I think I showed this before. So here we have sine x, negative sine x, cosine x, and negative cosine x. To differentiate, we go like this, and to integrate, we go like that. Yeah, so if right over here, if over here we differentiate and we have cosine, we go once, we get negative sine. Okay, we go another, we differentiate again, we get negative cosine. Okay, so we're on the right track. Over here, when we integrate, we're going this way, right? So we're going to integrate once, is negative cosine. Integrate again, that's going to be negative sine. So we're on the right track. Okay. Now we could already cross multiply, but right over here we're going to do something different. We're going to multiply this by this, and then we're going to integrate the product of this. Okay? So let's see what happens. We have cosine of 3 theta times negative 2. Okay? Cosine of theta over 2. And then we have negative times negative is positive, times negative is negative. So that's going to be minus 3 times 4 is 12 sine of 3 theta times sine of theta over 2. Okay? And then we have negative times negative is positive. So we're going to have plus 9 times 4 is 36. And then cosine 3 theta sine theta over 2. And then integral of that d theta. Now, why did we do this? Look at this. Look at this integral and look at this integral. What's the difference? It's just the factor, right? We have a different factor, but it's still the same. Okay? So what we're going to do is we're going to set that equal to the original integral, which is integral cosine 3 theta sine theta over 2 d theta. And then we're going to bring this integral to the other side, okay? Factor it out and divide by the factors, okay, on both sides. And then we get the answer. All right? So if we do the maths here, this is going to be 1 minus 36, which is negative 35, right? So in essence, integral of cosine of 3 theta sine theta over 2 d theta is equal to everything, okay, divided by negative 35. Okay, so it's going to be like this. So it's going to be, this is negative 2, right? So that's going to be negative 2 35 over negative 35, which becomes positive, right? So that's going to be positive 2 over 35. Cosine of 3 theta, and then we have cosine of theta over 2. And then we have this divided by negative 35, right? So negative 12, so negative over negative is positive. So plus 12 over 35 sine 3 theta sine theta over 2. And that's the answer, okay? That's the answer for this problem. And don't forget plus c, of course, your constant, your arbitrary constant of integration. Very easy, right? So in this case, we're trying to go back to, okay, at some point we have to go back to the same integral so that we can integrate that, okay, and then factor it out, divide by that factor, and then find the answer. Using, of course, the DI method, okay, the good method. So, but if you want to do it the classic way, oh my God, that takes so much time, so much work to do. One small integral, okay? So, but of course, if that's the case on an exam, oh well, bear with integration by parts, the classic way. You can't do anything about that. Thanks for watching. I hope you liked the video. And please subscribe, share it with your friends. Hopefully it's useful to them as well if you're taking Calc 2. So I'll see you next time.